This is Josh Mendenhall, and this is a discussion on the research topic of digital fabrication and its application in architecture. To begin, we'll look at what exactly digital fabrication is. Digital fabrication is a design and manufacturing process that takes computer-aided design and computer-aided manufacturing and uses that data to control equipment to produce different geometries in the real world. There are three methods to digital fabrication, and the first being additive manufacturing, which encompasses like 3D printing and any additive process of manufacturing. The second is subtractive manufacturing, which is CNC milling, laser cutting, anything that takes away. And then the third is robotic manipulation, which is using robots and AI to perform different tasks, repetitive tasks specifically, like folding, bending, and weaving. Looking into how digital fabrication can be applied in architecture, it can be applied in construction automation, new material development, new aesthetic development, formal element advancement, and open source design. And we'll take a deeper look into how it can be applied in each of these fields. So first, with construction automation, when it comes to the construction design process, the design and construction process, there's a lot of factors that limit this process, whether it's time, cost, material, productivity, weather, etc. There are so many different things that restrict the efficiency of the construction process, and automating several tasks and like bricklaying, assembling parts, simple tasks that takes away from human productivity. Using AI to complete these tasks can reduce the time and cost on a project and overall increase the efficiency of the construction process. When it comes to new material development, so a lot of present day materials used in construction and in design have a high carbon footprint and produce a lot of waste and have a very negative impact on the environment. And while this is trending towards more eco-friendly, environmental friendly materials, employing digital fabrication opens the way to use very natural elements that produce little to no waste comparatively to the materials that we use today in the construction process. Moving on to the aesthetic approach in digital fabrication, developing new aesthetics is probably one of the biggest. Materials and cost limit how we can form and generate aesthetics in architecture, but using digital fabrication, we can now create much more complex geometries through using different surfaces and ornaments and in our computer-aided design and manufacturing processes. Moving into how we develop and advance formal elements in architecture, using 3D printing which has probably been one of the bigger breakthroughs and is still reaching its higher limits, but 3D printing can be used to produce conventional forms in architecture, like slabs and walls that can be designed correctly to withstand corresponding loads, and use as little material as possible, and then also add an unconventional twist to these architectural forms that break the barrier of forms that we know as today. So like this picture on the right, it is a traditional form, but brings in this more abstract approach, and that's all because of digital fabrication and something that we aren't seeing until today. And then finally, when it comes to open source design, so open source software is this concept where a copyright holder has produced a software and allows users to change and distribute to the software. Um, and this idea is being shifted into implemented into architecture where a designer allows a homeowner per se to adjust a design or aspects of a design as they see fit, and digital fabrication and subtractive manufacturing specifically and the components that come along with that used from laser cutting, as you can see here on the right, open up a new doorway where homeowners can, after the fact or during, have a larger say and replace materials or replace different components of a design as they see fit in their design for their home or for a structure. And then lastly, looking at origami's influence on digital fabrication. So origami being the art of paper folding to develop shapes and figures, starting with this 2D piece, paper, but 2D flat surface that can be folded and manipulated to generate a complex form, is the same idea that digital fabrication is trying to do, moving from a complex 3D geometry on the computer and bringing it down into 2D pieces that can be 3D printed or laser cut, and then assembling them after the fact, and bringing that complex form into life is exactly what digital fabrication aims to do. So that the concept of this computer-aided design and bringing these complex geometries into life draws heavily from origami's the concept and the art of origami, and moving from 3-dimensional to 2-dimensional, and then back to 3-dimensional.